All right, today's lesson is going to be on classifying quadrilaterals. I recall that a parallelogram is an enclosed, convex, four-sided object whose opposite sides are parallel and congruent. And we know that the diagonals bisect each other. So we know opposite sides are the same. And we know that the diagonals, so I draw one here. We know that they bisect each other. That means this is going to be the same as this length, and this length is going to be the same as that length. All right. A rectangle is a parallelogram where all four angles are 90 degrees. All four angles must be 90 degrees. And the diagonals bisect each other, and they're the same length. So you have a situation here where not only do they bisect each other, but they have to be the same length. So that means all four of these are going to be the same length there. A square is a rectangle whose sides are the same. So on the square, all four sides have the same length. And just like a rectangle, the diagonals not only bisect each other, but they have the same length. So even the intersection is going to have the same length. So it's going to be all equal. All right, classify the object as a quadrilateral, rectangle, square, or all of the above. All right, so we're given this. We have a enclosed four-sided object. So we know it's a quadrilateral, but we don't know if it's a rectangle, square, right? So let's look at the diagonals. This is x, and this has a length of 5. So if this is a length of 5, this would have to be a length of 5 as well. But let's use algebra. I'm going to say 3x plus 10. We're going to set that equal to 20 plus x. And if I were to, let's say, subtract 10 to both sides, I get 3x equals 10 plus x. If I subtract x to both sides, I get 2x equals 10. And if I divide 2 to both sides, I'm going to get x equals 5. So what I got to do is I have to plug in x equals 5 to see if that's true. So we know x is 5. Well, right here it says 5, so x is 5, then that's true for that diagonal. And that diagonal has a length of 10, right? Because 5 plus 5 is 10. And let's test the other one out. Let's see, we have 3 times 5 plus 10. That gives us what, 15 plus 10? That gives us 25. And then we have 20 plus 5. That gives us 25. So yeah, the diagonals definitely bisect each other. But the diagonals aren't equal, right? Because I have a length of 50 here, and I have a length of 10. So it's definitely not a rectangle or a square. I classify the object as a quadrilateral, rectangle, square, or all the above. Well, let's see, 9 and 9. The opposite sides are equal. That's good. That looks like it's going to be all the above there, but we have to test out the base. So I get x minus y equals 9. And my other expression is x, well, the equation is 5x plus y equals 9. And we can solve this, right? You can use elimination. If I add these two equations together, I get 6x. I can that eliminates the y, because that's negative y plus y, equals 18. Divide both sides by 6, and I get x equals 3. So if x is 3, then I can plug it into here to figure out what y is. You can use one of the two equations. I'm going to use the top equation. So I'm going to say 3 minus y equals 9. And I can subtract 3 to both sides. So I get negative y equals 6. So y equals negative 6. All right, so let's plug it in. Let's see if it makes sense. So x is 3 and y is negative 6. So let's look at the top equation. I get 3 minus a negative 6. That does equal 9, right? I get 3 plus 6, that's 9. Then I get 5 times 3 plus a negative 6. That should equal 9. So that's 15. Wait a second. So I get 15. Minus 6. And that does equal 9. So not only is it a quadrilateral, but it has to be a rectangle as well, because all four sides have a length of 9. So this is a square. This concludes our lesson today for classifying quadrilaterals.